to episode 8 of the David Bernard Podcast. Today is June 1st, 2021, and you guessed it, today is the first day of the hurricane season. Nice to know there's nothing out there. We're not expecting development over the next 5 days, so certainly that's good news. Now, of course, we've already had one storm, and we're going to be talking about that a little bit on our show today. Anna, that was a couple of weeks ago. We seem to have more and more of these storms popping up in the month of May. Fortunately, Anna was out in the Atlantic and didn't do any harm to anyone. Our annual special, Weathering the Storm 2021, that is coming up tonight on Fox 8 at 6:30 in the evening. Hope you tune in for it then. If you miss it, we will be repeating it. And of course, it's going to be available on all of our digital sites as well. You remember, you can also watch a video of this podcast. That is available on our website at fox8live.com/David. Or if you happen to already be watching this, of course, we have an audio version available on your favorite podcast app, and I hope you subscribe because we'll have a lot more coming up as we go throughout the hurricane season. Fox8live.com, along with our Fox 8 News and Weather apps, they also provide live streaming of all our newscasts. This is particularly handy now that we're in the hurricane season. You can still watch us if the power goes out, but remember, you need to have a way to charge your portable devices, your iPads, your iPhones, your tablets with some kind of portable charger or battery to keep the devices charged even until power is restored. And I know a lot of people relied on that this past year during Hurricane Zeta when there was something like a 90% power outage for the metropolitan area. Well, today I'm having the honor of speaking with Dr. Jeff Masters. Many of you may know him from his blog on the Weather Underground website that he helped found. The blog was retitled Category 6 in more recent years. That unfortunately has gone away, and he has a new way of blogging that we'll talk about as well. I have way more topics than time that I could discuss with Jeff today, but we're going to stick to hurricanes as well as hurricane impacts that involve the Mississippi River. So let's bring in Jeff. Jeff, welcome to the podcast. Thanks for coming on.
Hey, happy to be here, David.
Well, I think it is the most obvious thing to start with. Today is June 1st. It's the start of the hurricane season, but in recent years, that hasn't really meant much. Now that we've had Anna a couple of weeks ago, that makes 7 years in a row we've had a named storm in the Atlantic before the official start, which is June 1st. And I believe my calculation's correct. Since 2000, there's been 12 storms since June 1st. And I'd forgot about the freak January hurricane of 2016, Alex, that developed, I think it was out near the Azores, of all places, which was certainly an anomaly. Is this, when you're talking about just May storms, is this in itself a climate signal, you believe, or is this just more a function of giving storms with subtropical characteristics a name or perhaps better observations?
You know, we haven't proven that there's a climate connection to these sorts of storms yet. There have been some studies done on, whether we should be seeing more storms when you boost the water temperature up to 80 degrees Fahrenheit, which is kind of the cutoff point. And it makes sense to me that if you're going to cause, the ocean temperatures to rise to that critical threshold, 80 degrees more often, which we're seeing in May now, you expect to see more storms. But so far, the research isn't showing that that's what's happening. These sort of short-lived storms you tend to get in May, they're hard to detect. And, in previous decades, before we had satellites, before we had the hurricane hunters, maybe we missed a lot of these. So the jury's still out. I think in another 10 years, we'll have a better idea whether this is truly a climate signal. So far, not sure, but it makes sense to me.
What about the fact of beginning hurricane season earlier? Do you think, June 1st, that's really a human-created date, right? There's nobody saying to us that it has to be June 1st. This is just based on the climatology and the most reasonable time that we expect to see storms. There was discussion with the WMO and National Hurricane Center. Should we start hurricane season a little earlier, May 15th? Is that just purely academic, or does that make a difference one way or another as far as public perception?
Yeah, I mean, the Eastern Pacific hurricane season has always started on May 15th, and this year the National Hurricane Center started issuing advisories on May 15th, which I think makes a lot of sense. And they went short of declaring the season to officially start then, but I really think it should start in May 15th because it was 7 years in a row, like you said, we've seen a May storm. So, yeah, the season is shifting earlier, and I think it makes sense. Let's make it May 15th now.
Okay, so we haven't established a climate signal for these May storms yet, except for the fact that possibly these oceans are warming. Well, they are warming, and the rate that they're warming is creating storms earlier. But a more definite signal is what's happening in the heart of the hurricane season, and in particular, rapid intensification. And rapid intensification is a phenomenon in these storms that, quite honestly, is very scary for us here along the coast. I'm just thinking back. I pulled the stats from 2020. You could go on and on and on about the different records and extremes that were broken, but 10 storms. We had 30 storms in 2020, so a third of the storms last year went through rapid intensification, meaning they were intensifying at least 35 miles per hour in a 24-hour period. I believe that's the benchmark, correct?
It is, yes.
Yes, and not only that, you had storms Iota and Eta that increased 80 miles per hour in a 24-hour period. In fact, Iota being the last storm of the season ended up being the most intense storm of the season. I know that they pulled it back from being a Category 5, but it still kept it at 155, which was a tenth stronger than, say, Hurricane Laura. And then Eta and Delta, 105 mile per hour increase in 36 hours. Why? And obviously, a lot of this has to do. I mean, last year in itself, we could say maybe it was the La Nina that helped to charge these storms, certainly later into the season, and keep them more intense. But overall, there's something else going on here. And if it's ocean temperatures, why do these subtle differences in ocean temperatures make such a huge difference in storm potential?
You have to understand that the atmosphere has thresholds where things can happen and then they can't happen when you reach that threshold. One of them is 80 degrees Fahrenheit. You really can't have hurricanes when you have a temperature below that. There's just simply isn't enough heat energy to power the hurricane. And so it makes sense that as every degree you go beyond that, you're getting a lot more heat energy. And so there are subtle thresholds where you can't get a mega, 160 mile per hour Category 5 unless your water temperatures are, I think 83 is the coldest I've seen for that sort of hurricane. So as we get warmer ocean temperatures, now you're opening the door for more intense hurricanes. And not only that, as you were mentioning, the rapid intensification problem is going to get worse. It turns out it's kind of an exponential function, where as you add more heat energy to the ocean, the amount of energy available to provide a rapid intensifier goes up not as a straight line, but as an exponential function, and like a power of 2 or 3 or something of what you might expect. So, yeah, we're opening the door towards more rapid intensifiers and more intense hurricanes, and both of these things have been connected to climate change.
Well, and so then let's circle it back to Southeast Louisiana here and the Gulf Coast. We need 60 hours to clear out this region from the coast to the metropolitan area of New Orleans, Jefferson Parish, St. Bernard, Placum, and St. Charles, our most populous parishes, and conceivably even areas on the north side of Lake Pontchartrain below Interstate 12 in a Category 4 or even 5 hurricane. Those areas need to be evacuated as well. And so the old saying, and what emergency managers have gone by for the longest time, is you always prepare for a category higher. Well, what do you do when the forecast is for this to be a 2, and then 24 hours from landfall, 36 hours from landfall, maybe say in the case of Laura, you're looking at a strong Category 4. What are the implications for that?
You got to scramble. I mean, that's tough because we saw this during Hurricane Michael too. it ended up hitting as a category 5, and it was not expected to do that. It intensified by 45 miles per hour in the 24 hours before landfall. And that's the biggest concern, the rapid intensifiers that occur right before landfall, because you don't have time. You're not expecting it to be that intense, and you don't have time to get people out of the way. I think it's inevitable that given the circumstances of more rapid intensifiers and more intense hurricanes, you're going to have a situation where you can't get everybody out on time. And certainly the biggest concerns are the New Orleans metropolitan area and then the Florida Keys. They're both very vulnerable and they need long evacuation times. The Keys, even more so than New Orleans. I think you need 72 hours to get everybody out in the Keys. So it's only a matter of time before we have a situation where you've got a bunch of people trying to evacuate and they're not going to get out in time. And it's going to be a more intense hurricane than expected that's going to cause a high loss of life.
Yeah, I mean, I think one thing that I think back to kind of in the, I say the old days, it was, I believe, 1999, Hurricane Floyd, when we saw that vertical kind of evacuation, that of course was, a big mistake, the way that happened, and all the people that could have been trapped on the highways. I think. I don't know if that same situation would happen here because we have multiple ways to get out of the area. In Florida, there's nowhere really to go, right? It's a sort of especially if you have a storm paralleling the coast. But think about Michael and Harvey and even Laura. Not to diminish Lake Charles, but it is a small community. Harvey hit at least as Harvey hit, its wind impacts hit an area of Texas that was not very populated, and same with Michael. So we've kind of been dodging the bullet on some of these rapid intensifiers as far as where they're hitting along the coast.
Yeah, we got very fortunate with Laura because if it had hit 150 miles either further east or west, it comes in either over New Orleans or over Houston, where you've got a much higher population that's not probably going to be able to evacuate in time.
Yeah, Sally, this year I'm talking about in on our special that's going to be on tonight. Laura and Sally, I use as an example of really the two worst cases for scenarios for New Orleans happen on either side of us this year. Sally being the storm approaching from the east southeast, coming in toward Breton Sound, which was sort of the original track, slow moving, potential category 3 storm, and then Laura, the last minute rapid intensifier. So those were two very nerve-wracking situations, obviously for us. The Laura track was a little more definitive for the New Orleans area, but at least for a time, the Sally one, that one was potentially much more problematic.
Yeah, Sally was a weaker storm. Laura would have been the bigger concern because the rebuilt levee system in New Orleans would not have been able to handle Laura's storm surge. It would have gone over the top and caused flooding in the city.
Definitely the case. So we're talking about these big storms, and one idea that you've advocated is, and hence maybe the inspiration for your former blog, the Category 6, that we'll talk about at some time, is that from a scientific standpoint, we might need to create a Category 6 hurricane. What is your thinking on that, and the evidence you've seen that support that idea?
There's two things to consider. One is from an operational point of view, it doesn't make sense to have a category 6 because category 5s are so rare anyway. It doesn't do you much good to add a category 6 in there. People are still going to get out of the way of a 5 or a 6, I would certainly hope. And the other thing is from a climate change perspective, maybe it makes sense to start talking about category 6 storms. If you extend the Safford-Simpson scale in its logical manner, you'd get a category 6 starting at about 190 mile per hour winds, 195 mile per hour winds, something like that. Now, if you take our best model we have right now for simulating intense hurricanes, it's called the high floor model. It's a computer model that's been developed over at NOAA. Then in the past climate of the 20th century, you'd expect to see globally one of these category 6 type storms every 8 years. Now, the high floor model is predicting a factor of 8 increase in those type of storms by the end of this century, so that you're getting one every year. And it's the high-end storms we're most worried about because they cause the majority of the destruction. In fact, if you look at the previous stats, Category 4 and 5 hurricanes in the US, even though they make up only 14% of all the landfalls, they've caused over 50% of all the damage. So it's really those high end storms we most worry about. They cause the highest loss of life, the most damage. And that's what modeling and global warming theory says we need to worry the most about, because it's going to be those upper end storms that are going to show the largest increase. And yeah, I think it makes sense. Let's start talking about category 6 storms, because yeah, if one of those hits a major metropolitan area, it's going to be like an EF4 tornado ripping through. But now instead of having a tornado scale damage path of maybe, half a mile wide, now you got a 20-mile wide path, 30-mile wide path, something like that. The destruction will be enormous.
Yeah, that's kind of hard to comprehend, and obviously we know what the result of something like that would be. I guess what about Dorian? Would that? I'm trying to think of maybe a storm that potentially might have qualified.
Yeah, Dorian was right at the upper end of category 5, low end category 6, if you want to call it, 185-mile-an-hour winds. We've already had one in the Pacific this year that was a Cat 6. It was called Taukte in April of all months. Just nuts. It was a 190-mile-per-hour storm. And in the Atlantic, we've only ever had one for sure. That would be Hurricane Allen of 1980, had 190-mile-per-hour winds. But Dorian was close, and Irma was close too. Back in 2017.
Yes, and I know some people that went through Irma in the Caribbean and around the island of St. Bart's, and where there were winds certainly measured in gust over 200 miles per hour on that particular island. Definitely a very frightening situation. And Allen, I do remember Allen, and not to date myself, but that's okay. My very first storm was Anita in 1977 that I tracked as a kid in the Gulf. I grew up in Houston. On the upper, and that was a Category 5 at one point. But Allen, I do remember seeing that. It literally took up almost the entire Gulf of Mexico. It was
it was enormous.
A massive storm. So, on that note, shifting gears here a little bit, before you became a co-founder of the Weather Underground that we're going to talk about, you were a hurricane scientist with NOAA, and you were flying into the storms. And speaking of Dorian, I have yet to fly with the hurricane hunters for a lot of reasons. A lot of them because it just the timing didn't work out. I had an opportunity to fly into Dorian at peak intensity, and that fell through, which really crushed my little heart. Of course, my mother was thrilled when she heard that had fallen through, and that brings us back to your experience in the 1980s flying with the hurricane hunters. Many people may know the story, read about your experiences flying into Hurricane Hugo. I can remember that storm. I was in university when that storm was happening. It was quite dramatic to see that storm, the way it intensified. And I can remember the late, great John Hope on the Weather Channel describing it. I can still see him this day saying something like, "We're looking at the strongest hurricane to approach the Carolina coast since I don't know when, a long time." And you were on one of the flights going into that storm. Maybe just briefly recount, what happened, because that's one thing people always ask me is, why do these people fly into these storms, and how come we haven't lost more people flying into these storms? We do it differently today than, say, when you were doing it with Hugo 30 years ago.
There have been 6 or 7 Hurricane Hunter flights that never made it back. And the most recent of those was back in 1974. And the old planes they used to use to fly into hurricanes were underpowered for that kind of work. They didn't have modern, jet engines like the current Hurricane Hunters have. So what they use to fly now into hurricanes are turboprops, which are a combination of a jet engine with a propeller on them. So you have the power of a jet engine to get you out of trouble, but at the same time, you've got the propeller, which slows you down. And that's helpful because the faster you fly into a hurricane, the more vulnerable you are to turbulence and what we call wind shear, which is a sharp change of wind speed and direction with distance. So if you're flying through, for instance, the eye wall of a hurricane, where you've got winds that very suddenly change in magnitude. Now imagine that your nose is in an updraft and your tail is in a downdraft. You're going to be experiencing some pretty severe torques. And the faster you fly, obviously, the more those torques are going to be affecting you. So since 1974, no Hurricane Hunter airplane's gone down. And that's about the year when we switched over to these turboprop aircraft. The Air Force flies C-130s, and the NOAA Hurricane Hunters, which I flew with, they fly P-3s, four-engine turboprops, very sturdy, excellent aircraft for flying into a hurricane. So you can do this safely. There are a number of rules about how to do it safely. And the number one rule, which actually went into effect after my Hurricane Hugo flight, is thou shalt not fly into a hurricane of category 3 or higher at an altitude less than 10,000 feet. Because the lower you are, the more severe the turbulence, and then obviously you're closer to the ocean. So if you get in trouble, you've got less room for error. So what happened back in 1989 is we were flying a two-plane mission out of Barbados. It was a hurricane research mission, as it turned out. And we took both of NOAA's P-3 aircraft into Hugo, which at the time we thought was a Category 3 hurricane. Now, one of the big reasons for flying into a hurricane is you want to know what its intensity is. You can't get that from just satellite measurements alone. They tend to be substantially in error, sometimes by as much as 20 miles per hour. You'll see a satellite estimate from the Hurricane Center of a storm, and then the hurricane hunters get in for the first time, and then you see, oh, well, it was really 20 miles per hour different than that. So it's very important to get that air truth, where you fly into the storm directly and measure the strongest winds and the lowest pressure. So we were doing that sort of research in September of 1989, and as it turned out, the Air Force was also sending an aircraft in to measure the storm. We were catching it way out over the Atlantic, between as the storm was coming across from Africa, and no other Hurricane Hunter airplanes had ever been in the storm. So we were the first. We had satellite measurements to go by as what we thought the storm was doing. So like I said, the satellite measurement said, Hugo's a Category 3. So we said, okay, well, we're going to be a little daring. We're going to do a research mission with one of our planes at low altitude at 1,500 feet. We got away with that the previous week in a Category 3. We don't ordinarily do that sort of flying, but it was an important experiment to try and understand what was going on at low levels. That's really critical for understanding the intensification process. What's going on near the surface has got major implications for how a storm will intensify. So we wanted to learn, how is it interacting with the ocean in order to do better intensity forecasts. So my plane went at low altitude at 1,500 feet. The other aircraft was in at high altitude up at 10,000 feet. And we did kind of this two-pronged thing where we both had Doppler radars. We were simultaneously measuring the winds of the storm to get a full 3D picture of it. Okay, so my plane went in 1,500 feet, thinking it was going to be a Cat 3. And once you hit the eye wall of a hurricane, you're really committed. You can't do much maneuvering at that point. There's so much turbulence that you're just going to have to gut it out, fly straight and level until you hit the eye where it's calm, where maybe you can do some changing of your course. So we hit the eye wall of Hugo, and immediately we knew that we had bitten off more than we should have. The winds rose to Category 4 strength right away, but okay, it's only 2 minutes to get through the eye wall to get to the calm eye. So we said, well, we'll gut it out. We'll plow through this hurricane at 1,500 feet, and when we get to the eye, we'll climb higher, because nobody should be in a hurricane at 1,500 feet. We're getting pounded pretty good here. After about a minute into the eye wall, we got a minute to go. We're hitting 0 G's of acceleration where you're weightless. You're kind of hanging there, and then you get slammed down with twice the force of gravity. And things are getting uncomfortable. The pilots are able to fight off the turbulence, but it is uncomfortable, and we're feeling nervous because you should not be in a Category 4 at 1,500 feet. The danger is too great that a big downdraft will splash you into the ocean. And we were certainly hitting big downdrafts. We were getting 10 mile per hour downdrafts and a few 10, 15 mile an hour updrafts.
Wow.
Okay, now we're getting closer into the eye. We're about a minute and a half in, only 30 seconds to go till we hit the calm eye. Now we're getting some really severe turbulence. the winds are category 5. And we're saying, oh crap, we're in a cat 5 at 1,500 feet. This is not good. 170-mile-per-hour winds, and the updrafts and downdrafts are getting even more severe. We're getting banged around hard enough so that now things we didn't fasten down good enough are starting to fly around the cabin. Things like, pens and clipboards. It's getting a little bit dangerous in there. But finally, we see it start to lighten up, and I say, oh, hallelujah, we're at the eye, we're going to make it. But right then, right as we're at the edge of the eye, we hit a 30-mile-an-hour updraft, followed by a 20-mile-an-hour downdraft, followed by a 40-mile-an-hour updraft, all in a period of 7 seconds. Now, at the same time, the horizontal winds went from about 170 miles per hour to 70 miles per hour, so they decreased by 100 miles per hour. That's a tremendous amount of shear. Now, the plane's bucking, up and down in the updraft, downdraft, and at the same time, it's skidding to the side because of that differential wind on the wings. And the pilot lost control of the aircraft. We start plunging down towards the ocean. And then at that moment, I hear one of the engineers say, we got fire coming out of number 3. Our number 3 engine had burst into flame. And inside the cabin, it was chaos. There was, headsets flying around, Coke cans, screwdrivers, you name it. Our 200-pound life raft broke loose, hit the ceiling. Computer flew off, hit the ceiling, tore a gash in it. We were really lucky that nobody got injured by flying debris. It was just absolute mayhem in the cabin. And fortunately, right then, it grew calm. We popped into the eye at 800 feet altitude, one engine in flames, and the pilot pulled us out of the dive, extinguished the fire in the number 3 engine, and leveled us out.
Let me ask you this. What you described right before then, those wild gyrations, and the change in wind that was so dramatic. What do you think there was something specific going on, maybe on a micro scale within that eye wall?
Yeah, absolutely. What's been learned ever since that flight, which we really didn't know, is that embedded in the eye wall of a hurricane, you can have what we call a mesovortex. It's a tornado scale spin that causes really extreme winds and low pressures. And it turned out the lowest pressure in Hugo at that time was not in the center of the eye. It was right there in the edge of the eye wall where we flew through. There was a little embedded spin there, and the pressure was like 10 millibars lower than it was in the center of the eye. And the winds were really extreme there. And it's thought now that these type of mesovortices are what cause a large portion of the damage you see in extreme hurricanes when they make landfall.
And it really was Hurricane Andrew when we became aware of that, right? Am I correct? That the research.
Yeah, 3 years later, Andrew had a similar sort of mesovortex structure in the eye wall. And yeah, they studied that and said, oh, okay, just like Hugo, we're getting these little vortices that are causing this damage.
All right, well, Jeff, I'm glad you made it out of Hurricane Hugo. There is a more full account of it online, and a little bit later, I think you have your book that you're still trying to get out there that we could talk about. But you can still find the story, the complete one, online. But that gives you a taste of what he went through. Wow. So that was it with you and hurricane hunting, I guess.
Well, let me add also, the Smithsonian Channel has a series called Air Disasters, where they did a 45-minute episode on that flight, and they interviewed you and the pilots, and they actually had a set in Toronto where they built a copy of the cabin and shook it around, and they had actors play all the scientists and the crew.
Oh boy, but still not the same as the real thing, I'm sure. But maybe gave them a little bit of a taste of what actually happened. And so
yeah,
that was
want
your
to go on that flight now.
yeah. So that was your background in hurricane hunting and with NOAA, and from there, I believe you'd gone back to get your PhD, and in the process helped to co-found the Weather Underground that so many people became familiar with, and of course your blog. Which really, I guess, made you famous and that people relied on quite often. I mean, just briefly, maybe just talk about how the Weather Underground got started. The Weather Underground, that was sold. You did sell that. That was the Weather Company, and it's been merged into IBM in recent years. But maybe a little bit about that and about how your blog started. And I'm also interested in Katrina because it was an opportune time, I guess, to start blogging. You started blogging in 2005.
That's right. Yeah, we founded Weather Underground back in 1995 as a company. And before then, it was a educational project at the University of Michigan, founded by my PhD advisor and then some of the students, including me. It was actually the predecessor to the website was a text-based service where you could type in a three-digit or a three-letter airport code, like you know, MDW
MSY.
for Chicago. Right, yeah, right, and get a forecast. And back in 1992, I wrote a little program to do that, and it was the most popular service of any kind on the entire worldwide internet for almost 2 years. That little text-based weather program
Wow.
I wrote. So the National Science Foundation took note and said, "Hey, this is great stuff because we really want to push the internet and we want to push science education. And what more natural use of the real-time capability of the internet could you do than do weather?" So they funded us to do weather, and that was the original Weather Underground, which actually got its name from the radical wing of the Students for a Democratic Society, which also got it started at the University of Michigan. So it's kind of a tongue-in-cheek play on words. And perhaps unwisely, we kept that name, uh, and we spun it off as a company in 1995, and slowly built a following. And it was hard to get a business running back then, just on revenue from advertising, because advertising was tough
Right.
to do. They didn't understand how to advertise on this new media. But anyways, yeah, by the early 2000s, we were doing pretty well, and by 2005 I wanted to branch out and do more than just computer programming, which was primarily what I did for Weather Underground for the first 10 years. And I started writing a blog. I didn't know what to write about us initially. I started in April 2005. And boy, when the hurricane season of 2005 came along, I certainly had a lot to write about. And like you alluded to, Katrina in particular in August of 2005 was a, a real watershed for me. I mean, I had written about the other storms that year. We had a couple severe ones already: Cindy, which hit Louisiana, and then Dennis, which hit the Florida Panhandle. And okay, I was starting to get a little bit worn out here by late August, and I was thinking, okay, Katrina, yeah, it's going to hit Florida, and then it's going to hit the Panhandle again. I can probably take a weekend up north and visit my dad because I haven't done that this summer. And I was thinking Katrina was going to be no big deal. So Cat 1, it's going to hit the Panhandle again. They already get hit by Dennis, no biggie. So I go up north to visit my dad that weekend, and he had a modem, a very slow modem, and I was trying to blog on that modem during Katrina. And each day, I got up there. I think it was on a Thursday. I'm, writing about Katrina, saying, well, it's going to hit Florida and be a Cat 1. And then we don't think it's going to be a huge deal for New Orleans. But then by Friday, before it hit Sunday night in New Orleans, I was spending more and more time up in the computer room above my dad's place and typing out on this slow modem. Okay, oh, here's a new model run. Oh, this looks really bad. Uh-oh. And then by Saturday, I was basically spending my whole day, on the computer saying, you guys, if you're in New Orleans, you got to get out. Get out in capital letters. Get out now. I don't care if no evacuation order's been ordered. This is going to be bad. And, the models are coming into greater alignment, and you're not going to be able to go to work on Monday anyway. So get out of the city. And
Yeah.
I heard from a lot of people afterwards that my blogging was the thing that made them leave. And I was like, wow, maybe I saved a few lives. I don't know. But that was a crazy experience trying to blog through that on a modem and seeing what, would become the most severe storm in U.S. history as far as deaths and damage go up until that, in modern history, I should say. Just an absolute crazy experience for everybody involved, including me.
Yeah, I mean, at the time, I think a lot of people out there know this, but I was brand new in Miami when Katrina struck, and I just moved from New Orleans to Miami. And I remember I got off the late news that Friday night, and I saw the model runs, and I saw what the storm was doing in the southeastern Gulf, and I was on the phone all night. In the middle of the night, I was calling people at 3, 4, 5 in the morning. They weren't happy with me, and they knew because I told them before on storms, this is okay, that's not okay. This one I said, this is definitively not okay. And really, as we know, to get people
Yeah.
to move is very difficult. And New Orleans had been really spared anything terribly significant just for decades. Probably really having to go back to Betsy was really
65, yeah.
65, the last significant impact. And for a lot of people and younger people, they didn't even remember that. So again, that helped put the blog on the map. And like so many other fellow meteorologists out there and just the general public, have really enjoyed your blogs over the years. One thing I know that you've written a lot about is the Mississippi River. And we can only talk so much about the Mississippi River today, but since it's the first day of hurricane season, maybe I'll just keep it in the context of the Mississippi River and surges. And the first topic I want to talk about is Hurricane Isaac in 2012. And we just had Zeta this past year. This was really our first strike since Isaac, a completely different storm, right? Zeta was coming from the southwest, which had less of a storm potential. It was a rapidly moving storm. So as far as surge goes, not the same kind of impact that Isaac did. Isaac was the first real test of the levees post-Katrina. There was Gustav, but Gustav, the levees weren't anywhere near completed. There was still overtopping in some weakened areas. But I think Isaac was the first real test. Some bad things about Isaac were it was slow moving. It was category 1. But as we know, a slow moving category 1 has a different surge potential. We don't relate the category with surge now. That's really a separate item. And so it was producing a greater storm surge than a category 1 because of its slow movement. In this situation, the levees worked, and we didn't have a surge on the river that caused, say, overtopping of the Mississippi River levees. What was working in our favor in that time? Why did all of this work?
Yeah, the levee system performed to specification. I mean, they're supposed to be able to withstand a Category 3 storm surge, 15 feet. Isaac brought about a 10-foot storm surge, and it was really heartening to me to see that the levee system came out without any failures. I mean, in some places, the surge was more than Katrina brought to New Orleans. So that gave me a lot of confidence that the Army Corps did their job, did it right. So it was good. The other thing that went right is that the Mississippi River was not at flood stage. Had it been at flood stage, there would have been a real danger of, okay, now the winds from the storm as it approached are blowing from east to west. They're going to push a lot of water into the Plaquemines levee. And when it hits that levee, it's going to be stopped. It can't go any further. And then it gets forced up the river towards New Orleans. And in fact, a 10-foot storm surge went up the river to New Orleans. And in fact, there were several feet of storm surges observed all the way up to Baton Rouge and even further north than that. So fortunately, the Mississippi River was more than 10 feet below the tops of the levees at New Orleans. There wasn't a danger of those levees being overtopped.
Now, if it had been a different situation, we're going to talk about Barry in a minute. But just kind of to back into that, at least, and talk a little bit about my experience, the first time I ever heard anything about a surge on the Mississippi River was in 1998 during Hurricane George. I was brand new in New Orleans, still relatively young broadcast meteorologist, and people started talking, George is going to bring, and do you remember George? How the track, how it was coming kind of from the east southeast. It eventually went into the Mississippi Gulf Coast and caused surge on Lake Pontchartrain, but did not cause the significant surge on the Mississippi River. But I started thinking, what is that process? You started to talk about it a second ago, but maybe explain a little bit more to folks out there exactly how a surge moves up the river and how it reacts with the water that's already there.
So what happens in a surge is that the winds of the hurricane are blowing water, and if you have a very shallow area of the ocean, there's really nowhere for that water to go other than to just pile up. Now, if you got a deep ocean, then what happens is the water kind of mounds up and then it can sink down towards the bottom of the ocean and flow out away. But if you've got a continental shelf situation, then you can't get that to happen, and the water just piles up higher and higher and higher. And also, about 10% of the storm surge is just due to the low pressure. It's like, a hurricane's a low pressure zone, like a straw. If you're sucking up on the water, it helps, pull up the water more. So now you got this big mound of water that's moving forward. And if you've got a slow moving hurricane like Isaac was, you've got more time for that water to be there and to penetrate up into narrow estuaries like Mississippi River, which was the issue with Isaac. So as it turns out, like I was saying before, the levees actually can trap the flow. The west side of the Mississippi, you've got a levee there in Plaquemines Parish. I don't know if I'm saying that right.
Plaquemines.
Plaquemines. Okay, but on the east side you don't. So the water comes in and then it's trapped there, and it's got nowhere to go. It can go downriver, I suppose, but the angle of the wind was such that it pushed it upriver, which is kind of a problem in that you could redesign that levee system and put a gap somewhere. I don't know. I'm sure the people in Plaquemines would not be happy about this. But if you put a gap in the levee there, then the water wouldn't be trapped there so much and you wouldn't get so much flowing upriver towards New Orleans. But the water's got nowhere to go, so it moves up the river. And it's a difficult situation to try and forecast because you don't know. Maybe part of the levee system will get overtopped on the way where you won't have as big a storm surge. It's a very complicated sort of flow structure there. A lot of different pieces of levees and a lot of estuaries, and very tough to forecast.
All right, so let's now go to Hurricane Barry or Tropical Storm Barry in 2019. And that was sort of the nightmare scenario that the blog I had read of yours back in 2013, talking also about the potential economic impacts of something like this, of a shutdown of the Mississippi River, if you had significant disruption along there. But with Barry in 2019, there was a lot of angst. The difference with Barry and Isaac is the river was at 16 feet.
Right.
When the storm was approaching, and the flood stage at the Carrollton Gauge on the Mississippi in New Orleans is 17 feet. The levees protect to 20 feet at least. They're higher in some locations. I know there was a little bit of controversy there, but it seems to have been ironed out that most of the levees are at least 20 feet in height. So we had Barry, an early season storm. The river is at 16 feet, but we never reached that overtopping forecast. I think the forecast was at 19-20 feet. I guess I'm going to ask you to say put Barry in 2012 with Isaac to say what that would have looked like. But I guess also maybe part of the reason I feel the Barry forecast kind of, I don't want to say flamed out, but didn't materialize was the storm was more disorganized, I think, than certainly Isaac, which was a much more compact, more mature storm, a Category 1. And maybe the track may have played a role with Barry as well, which sort of scooted along down to the south and kind of came up more into Acadiana. Compare those two, the Isaac situation and the Barry, and what that would have looked like, God forbid, if the Isaac situation had been in 2019 with the river so high.
Yeah, Barry hit in second week of July. River was 4 feet below the levees. And the original forecast had a 4 foot storm surge coming up the river, but that expected Barry to organize into almost a Category 1 by the time it passed the mouth of the Mississippi. And Barry held off organizing until it got past there. It was further to the west. So lucked out there. It only sent about a 1 foot storm surge up to New Orleans, which still kept it 3 feet below the tops of the levees. But yeah, if we had had a Hurricane Isaac hit in the second week of July with the river running so high, now Isaac put about a 10 foot storm surge to New Orleans. And if the river were already at 16 feet, then that would imply 26 feet of water at New Orleans. So that's 6 feet of water over the tops of the levees. I don't think it would have been quite that much because you might have had some overtopping before the storm surge got to New Orleans. Some of the levees below, south of there, would have failed, and you wouldn't quite have seen that sort of water.
Also, if the river is that high, there's something to be said about the flow, how fast the flow of the water is coming down the river, and how that would have counteracted with the surge trying to come up. I assume that a really low river, more surge is able to penetrate farther upriver than, say, if the river is really high.
Yeah, you're absolutely right. When they do the storm surge modeling, it shows that at low water, low river flows, you do get a higher storm surge coming up the river.
All right, so that definitely could have made a difference. Well, Jeff, it has been great having you on the podcast. I'd like to do another one with you in the future, specifically more about the river and talking about the old river control structure and the future of the Mississippi and New Orleans and the possibility that this river, well, it has changed course in the past and it's probably going to go to again. There's a lot of ramifications as far as that goes. But we don't have time to get into it today. But certainly that's an issue, and I guess you could say right now something that we need to be really looking at more seriously.
In the long term, the water always wins. And New Orleans is built in a place where it's beset by water on all sides. So we got to make some hard decisions about the future of New Orleans. New Orleans in its current state cannot exist in the long term.
Well, that's a pretty frightening statement. And again, but there are things that can be done to save parts of the city. And we're talking, these are things that could happen, many years in the future. This is not something that's necessarily going to happen tomorrow, per se, just for people listening.
Yeah, I mean, if you think about the risks for New Orleans, the levees are rated for a 1% storm, a storm that has a 1% chance of occurring in any particular year. So over a 30-year time period, that's 26% chance that the levees will not be able to hold back a hurricane. So over a period of decades, the risk will increase. And any one particular year, you're going to be fine. But I'm just talking in very long terms. The odds are New Orleans is going to be fine for the next 30, 40, 50 years. But after that, you start rolling dice that often, and you're going to not make the right roll. You're going to roll snake eyes one of these years.
Well, we're going to talk about this old river control structure with you another time. And just for the people listening out there, it involves how the river is interacting with the Atchafalaya River Basin and other things like that could eventually change the way that the river does flow. I would add what you say, the water always goes where it wants to go. One of the most impactful maps that I did see after Katrina was the Times-Picayune had a map where they overlaid the floodwaters and where the water went to after the levees broke over a map of the city. I think it was from the 1870s. And this is before they started filling in the wetland closer to Lake Pontchartrain, the more low-lying areas of the city right now. And literally, the water stopped where the houses began. and so that just, really emphasized the fact that, we can do all the engineering we want, but in the end, Mother Nature is going to decide how this water is going to flow. You've got a new blog site that you participate with, YaleClimateConnections.org. So maybe if some folks had lost you a bit because of Category 6 unfortunately going away, they can still catch you there.
Yeah, and I'm also trying out for the first time this year. I've gotten active on Twitter. I'm Dr. Jeff Masters, Dr. Jeff Masters. I don't have very many followers yet. Please become one of my followers, and I'll try and do a good job on Twitter.
Yeah, and it's Twitter. Be careful out there, Jeff. That's all I have to say
I mean,
about
it's
that.
wild, wild west out there. It's crazy.
Okay, finally, the David Bernard podcast, we like to ask, you knew you were a weather geek when?
Oh, yeah. Growing up in Michigan, when I would stand outside in major snowstorms in my backyard and watch my wind gauge on my home weather station as the wind gusts would move along and write down, what the wind gusts were because you had to be standing out there in order to see what they were.
And that was it. That did it.
Yeah, yeah. Well, growing up in the Midwest in general, they say wait 1 minute and the weather will change. And boy, it was sure exciting to grow up in that sort of a situation.
Jeff, it's been great having you on the podcast. Thank you so much for your knowledge and insight, and we hope to talk with you again soon.
Thanks for having me, David. Good luck down there in hurricane season.
Thank you. We're going to need it.
Okay.
That'll do it for episode 8 of the podcast. Join me next week for episode 9 when we talk with one of the preeminent hurricane chasers, not only in the United States, but also around the globe, Josh Morgerman. He's known as @iCyclone on Twitter, and he's going to be talking about his experiences not only chasing storms along the United States coast, but around the world. Last year, as of note, he was based in Bay St. Louis because of the pandemic. He could not travel internationally, and that proved, unfortunately, to be the exact right spot to be as far as landfalling storms went during the 2020 season. So it should be a really interesting conversation, and I hope you tune in for that next week for episode 9. Until then, stay safe, everyone, and let's all get prepared for hurricane season 2021.